What the hell? Oh my God, no way.
Okay, first I recall. In the figure given, theta is an angle. If sine theta is equal to root 3 over 2, which if you recall, sine theta is opposite over hypotenuse, what is cosine theta? Well, first off, we have this weird looking circle, which is a unit circle, with a line drawn to the origin and an angle theta. And if you see closely, this makes a right triangle, where sine theta is our opposite over hypotenuse. Therefore, opposite of the angle is root 3, and hypotenuse, in this case, is 2. And the side that we don't know is b. And now, using our Pythagorean theorem, because this triangle is a right triangle, we say a squared plus b squared equals c squared, where our two legs squared equal our hypotenuse squared. So that is root 3 squared plus b squared is equal to our hypotenuse, 2 squared. So once these get squared and simplified, we get 3 plus b squared is equal to 4. And we get b is equal to root 1, which we all know is equal to 1. So now we know that b is equal to 1. And now we have all the necessary details to find cosine theta. Now, if you recall from your trigonometry class, cosine theta is adjacent over hypotenuse, which adjacent just means the angle next, the side next to the angle. So that would be, in this case, b, which is 1, over hypotenuse, which is 2. So our answer should be b, right? No, but since we're on the negative, or the quadrant 2, notice how in quadrant 1, x is positive, but in quadrant 2, x is negative. And since cosine theta is a negative an x value, the quadrant matters here. Therefore, cosine theta, because we're in the second quadrant, is a negative value. Which means our answer is C. A circle in the xy plane has a center at 2, negative 3, which is h and k, and has a radius of 7. An equation of the circle is whatever this monstrosity is, but please note that 0 in this case is not r, so it is not our radius. And we're trying to find c. Well, we know, because we're given an equation, that c is a constant, meaning that it doesn't change. It's going to remain that value, which is very critical for what we're about to do here. So if we recall our circle formula, which is x minus h squared plus y minus k squared is equal to r squared, our radius squared. By opening the binomial or squaring the binomial, we get x squared plus h squared minus 2xh plus y squared plus k squared minus 2yk is equal to r squared. So now we have this even worse looking equation than before, but the plan here is to plug in the values we were given to match up these equations. So x squared plus our center, which is 2, since it was given, 2 squared minus 2x times 2, because of h, plus y squared plus our y coordinate of our center, which is negative 3. So this will be negative 3 squared minus 2y times negative 3 is equal to r squared, which we know is 7. Okay, so now x squared plus y squared, and then we can just play a game of mismatch now and just match up our equation. So a in this case will be negative 4x, and b in this case, which is our constant with the y value, will be 6y, and our constant c is 9 plus 4 is equal to 49 because it's 7 squared. So if you look over now, we have this equation matched up. So if we were to rewrite this equation, we would get minus 4x plus 6y plus 9 plus 4, which is 13, minus 49 is equal to 0. And now, this equation looks exactly like the one on top that we were given. So by matching up our values, we see x is x squared, y is y, a is negative 4, b is 6, and c, these two numbers, 13 minus 49 would equal c. Therefore, c is equal to 13 minus 49, which gives us negative 36. Okay. Third and last one. In triangle XYZ, angle Y is a right triangle. The measure of angle X is 34 degrees, and the length of XY is 40. So if we were to draw this out, this triangle, angle Y would be our right angle, and X would be our 34 degrees. Z would be here. We know this side is 40, and we'll say this side is X, and this side is, for sake, let's say A. If the area in square units of triangle XYZ can be expressed as K tan of 34 degrees, where K is a constant, what is the value of K? So we know that the area for a right triangle is 1/2 base times height. But we can express this area in terms of K tan 34. So we can say K tan 34 is equal to 1/2 base, which in this case we have as X, and our height, which is 40. So from geometry class, if you remember, tan of 34 is opposite over adjacent. Therefore, we're going to get X over 40, giving us K of X over 40 is equal to 1/2 X times 40, which just simplifies to just 20x. Then, if we multiply by the reciprocal, 1 over x, to cancel out our x's, we get K of 1 over 40 is equal to 20. And then, once we multiply the 40 on both sides, we get 40 times 20, which is just 800.